The slides will be available. We'll send it afterwards.
Okay, thanks.
So I'm presenting the screen. I'm assuming that everyone is seeing my screen, right?
Yeah,
Sure.
we do. Yeah.
Absolutely.
Perfect. So very nice to meet you all. My name is André Vieira. I'm currently leading here the Communication and Adoption Working Group in Sylva. And we are very excited today to present this project. So how do we want to divide the presentation today? We are going to present the problem that this project identified and the, the, the mission that is proposing to solve it. Then we are going to talk about the approach, how we are seeing the pillars to solve this, and the governance also of the project Sylva. And then we are going to explain how we are doing it and talking a bit also in terms of the roadmap, what we achieved so far. And of course, talking in a bit of detail about the platform and the validation center. So beginning with the why this project appear? As you know, CSPs, telecom operators, begin their journey in the telco cloud and edge for almost a decade. So it was very long ago. And we are seeing a siloed approach. So the historical model doesn't fit on the multi-vendor approach. We want to shift to a common cloud layer. We are seeing some security threats and operators are increasingly threatened by hackers. In Vodafone Portugal, where I'm from, there was a big security issue last year, and it's getting common. New network functions. So we are seeing also the network functions changing, the such called VNFs to containerize network functions. It's important to have these network functions that require the cloud native infra and distributed cloud for these use cases that we all heard about O-RAN and 5G core and CDN. So to shift this VNF to CNF. And last but not least, in terms of lack of automation, it's on mind of everyone. So the automation, it's not done, and it needs to have the continuous innovation and service automation to shorten the time to market and to reduce the OPEX, everything that everyone nowadays is trying to achieve. So what is the mission statement of this project and how it appears? It was a consortium of the main carriers in Europe together with network function providers, so Nokia and Ericsson. They all get together to initiate the project to address the telco and edge use cases. So the main objectives are two. First one, to release the cloud software framework to the homogenization that we talk about and tailor for the telco and edge requirements, and to address all the challenges that we talk about in the last slide. But also to develop a reference implementation of the cloud software framework and to create the validation program, very important to maintain this homogenization. And this project is beneath the Linux Foundation Europe. So what are the opportunities that we want to unblock? And here going on these four verticals, the technology, business ecosystem, and regulation and security. In terms of threats, so in terms of technology, is technology partners and slow innovation. With Sylva, we want to make these as more open as possible instead of proprietary solutions and to simplify and automate the operating model that we currently have. Right now, we also have, in terms of business, very lock-in and high prices. It's to reduce the cost, open source, mutualization, and of course, the interoperability of this platform. In terms of ecosystem, we see the ecosystem very fragmented in terms of the telecom operators and hyperscalers entry. So we want to have the common telco technology and to converge the telco cloud layer. In terms of regulation and security that we merge on this vertical, there is a strong regulation, as you know, and high cyber risk. So what Sylva can bring also is the compliance of European regulation and high security standards. And what is our approach? What are the five technical pillars that we are betting to do all of this? The first one is in terms of network performance. It's a bit different to network performance that a CNF or a VNF has for other common virtual workloads. So the network performance is a must. And to answer the CNF requirements and performance, we are focused on the SRIOV and the low latency on all these specific requirements that are needed to run CNFs, to run telco cloud workloads on container as a service and on bare metal. In terms of distributed cloud, the cloud is more distributed than ever. Is also to have the bare metal automation, but also the multi-Kubernetes optimization lifecycle management. In terms of security, it's really important, and it's also a pillar that we are having a working group, and you are going to see that in the image that I'm going to share with the governance, and to have the best-in-class security. Security is really important for us. Then to maintain as open as possible the open source and standardized API to support multi-vendor CNFs and to boost market adoption. We know that with this we bring a lot of innovation on the table, and of course it boosts also the development of the platform. Last but not least, something that also with automation people talk a lot is energy efficiency and to measure and optimize the limits of energy consumption. So how to make this more energy efficiency possible. It's really important. We are having workloads and a lot of workloads in the cloud, and we need to be energy efficiency, not only of everyone knows about the price of energy, but also to be greener and to have a leaner operation, to have less OPEX at the end of the month. So how is Sylva divided? What is the governance? We call it work groups in Sylva. So we have the first work group is the telco cloud stack that is being led by Mathieu. Then we have the validation center led by Luis and the security by Teofil, energy efficiency with Nokia, and communication and adoption by me, and evolution and governance also by Theophil. Then we have the technical steering committee that is composed by Orange, Deutsche Team, Telefonica, Vodafone, Nokia, and Ericsson. And now that we understand why we need this project, now that we understand also the approach and the pillars that we are betting and the governance that we are, what are the adoptions benefits and going on the deep dive of how we are doing. It's always good to how we are doing to understand, because this is a jointly project, to understand what are the benefits for everyone that is participating. So as you know, it's not only telecom operators, it's network functions, it's system integrators, hardware and different providers. What is going to be the future state and how Sylva will help each one of these stakeholders. In terms of telecom operators, the current state is that they have a siloed approach. The time to market is very high. It's too high for these type of workloads, and the different software architecture for telcos delays the innovation, so it's very closed. What the Sylva will bring to the telecom operators is a common cloud layer. Of course, this will reduce the cost. This will create the continue also with the MEC, enabling also some very nice use cases that we are seeing in the news, and to create the silver restaurants for the network validation, so to decrease the time to market of new service and market prospects. So a network function is validated in Sylva, can be implemented on any telecom operator, not needing to have again to do the validation, to understand the certification. And of course, the certification cost and time of network function will decrease a lot. In terms of network function providers, the current state is an heterogeneous cloud layer, so delivering a network function software release to different telecom operators can be really difficult. With Sylva, they will get an homogeneous cloud layer that enables the build once deploy many in terms of telecom operators. They will reduce the cost and time of the certification and some of the big headaches that they currently have, and also to provide an environment to test telco grade capabilities in the network functions. For the system integrator, the current state is a high risk project to do this. It's very, again, heterogeneous. Each case is one case, a lack of compliancy. These will have the system interoperability and compliance, and also new business opportunities to create a distribution out of Sylva, to provide deployments, and to provide validation service for network functions. The last one, the hardware and different providers, is in terms of lack of telco grade capabilities, visibility, and custom development. These will obtain the information of telco grade to reduce the costs and showing hardware enabled capabilities and the standardization of development. So how we are doing each of these streams, these stakeholders will benefit from this, and to explain also in terms of the ecosystem that is inserted. So Sylva is compliant, and of course, it's a Linux Foundation Europe project. We know when we work together with very important projects such as Anuket, such as Nephew, that and Oran, of course, that we want on this ecosystem to don't reinvent the wheel, but also to enable the synergies that we can have for other projects that already exist. So we are inside of these. We don't overlap with any of these projects that are here represented. We enable also other capabilities that we have. It's always to think about the open community, and we deliver value of what is currently not there. So in terms of architecture, to begin to do the drill down of the platform, in terms of architecture, as you can see, as a Casa management cluster can be on top of VMware on OpenStack, can be on bare metal on Edge on central sites, but this is to address the 5G core distributed and Open RAN, and Sylva will provide architecture to able to manage from central to far edge sites. So it's not on the central site, it's also on the edge and far edge to cope with all the use cases that we are seeing, and really important on the futuristic use cases that are talking in the industry. Just a note that this is an example. Also, Sylva could be deployed, but this can have, as you might understand, different models. And then to talk about the HLD, I don't know, Guilherme, if Matthew is here or if you want to.
Alessandro is here. Alessandro from Telecom Italia is a core developer of the project.
Sure. So I'll pass the word to Alessandro.
Thank you. So hello, this is Alessandro from Telecom Italia, and I'm currently contributing to Working Group 1. So briefly explaining what we are doing in Working Group 1. Sylva is mainly an integration effort, I would say. So we are picking and selecting the most suited project from the open source community. The two main components that we are integrating that we have been integrating since the beginning were Cluster API and Flux. Cluster API, as you may know, is a main open source project from the Kubernetes community. And it's essentially an application of the Kubernetes resource model to manage the life cycle of Kubernetes clusters. So Kubernetes clusters for Cluster API are managed like usual Kubernetes resources. So what are the advantages? The first advantage is that the cluster that we want to create can be described using a declarative approach, a declarative model. Second advantage is that the controllers built in Cluster API take care to reconcile the observed status of the clusters with the desired status that we described in a declarative way. So this is the main advantage of Cluster API. On the other side, the Cluster API is also flexible, both in terms of infrastructure. As you can see in the current picture, Cluster API can support a number of different plugins to interface with multiple target infrastructure. So we are currently focusing on on-premises infrastructure like OpenStack, VMware, and also bare metal. Cluster API is also able to create clusters on hyperscalers cloud technologies. So we will probably plan to extend the number of supported infrastructure in the near future, but for the moment we started working on on-premise solutions, so VMware, OpenStack, and bare metal. On the other side, the cluster API is also flexible in terms of, let's say, Kubernetes distribution that, let's say, control plane implementation that is supported by the system. For the time being, we have been using kubeadm and also RK2 from Rancher, SUSE Rancher, for the implementation of the control plane, but in principle, other control plane implementation can be used as far as they can be integrated within the cluster API framework. On the other side, we are also using Flux. How are we using Flux? I said before that with the declarative approach, we can describe the desired status of our target cluster. This description that will be in the form of a bunch of YAML files can be pushed on a Git repository, and Flux will take care to synchronize the status of the Kubernetes clusters with the desired status of the target cluster that we want to create. So I forgot to mention the role of the management cluster that you see here at the center of the picture. So the management cluster is the cluster that we use not to host telco application, but to host the tools that we use, let's say the Sylva tools that we use to create a workload cluster that you see here on the right of the picture. So the management clusters will have Flux and Cluster API installed, and is the engine that we use to deploy the workload cluster on the right side of the picture. So the workload cluster are those clusters that at the end will host telco application. So the second part of the integration effort that we are pursuing in this phase is to be able to let's say, install and configure automatically all the features that we know we need to run a telco application. So Multus, SR-IOV, tuning the performance at the operating system level, CPU management, storage, etc. These are the other kind of features that we are integrating in the system in order to automatically install and configure everything is needed on the target cluster. Again, also in terms of supporting infrastructure, you see that we are currently able to manage the same infrastructure both from the management cluster and also for the workload clusters. Obviously, the bare metal scenario is currently the most complex to integrate. It has a few special needs that we have to take care from the automatic installation and configuration of the operating system and etc. So summarizing, Cluster API is the central component to leverage the Kubernetes resource model and to have the declarative approach and reuse the reconciliation mechanism that is built in Kubernetes. Flux to leverage GitOps approach. So everything we push on the Git repository will be automatically deployed in the network. So when we want to create a new cluster, we will push the corresponding declarative description on the Git repository, and then let's say the Kubernetes automation will take place. Third phase, integrating everything else is needed and we need to install on the clusters in terms of infrastructure. So storage, networking, CPU optimization, etc. In addition, we are also working on security and monitoring aspects that obviously are extremely important. So we want to have a full set of security features, from managing the secrets or to the certificates needed by the applications, and same from the monitoring system. So we in this first phase of the project, we mainly worked on the automation of the creation of the management clusters. So we mainly worked on cluster API and Flux. In the next few months, we plan to let's say consolidate what we are doing on security and monitoring, and also extending the other feature that we need on the cluster. So this is in summary what we have been doing in working group 1 until now. Thanks.
Thank you, Alessandro. Now to the validation center. I don't know if Louis is on the call. Today I only have one monitor.
Yes, I am, but
I'm sorry.
Guillermo will be talking about the validation today.
Okay, thank you very much. Can you hear me?
Yes. Yes, we can.
Okay, perfect. Thank you very much. This is Guillermo Carreto talking from Telefónica, and I'm going to explain you about the validation center in Sylva. Okay. As commented before, the main goal of Sylva is to create a cloud software framework, integrating the capabilities required for telco and edge workloads, implementing this cloud software framework, and create a validation program for this implementation. Okay. In the following slides, I'm going to introduce to you this validation program, which in Sylva is called Validation Center, and it's developed in the working group 2. Okay. As you can see in the slide, the validation program is divided in 2 different parts. The first one is the CNF validation program, and the second one, the derivative stack validation program. I want to highlight that currently only the CNF validation program is active because there is not any derivative stack ready yet to activate this derivative stack validation program. But in the future, when new derivative stack exists, then it will be started. Okay. Focusing on the first one, the CNF validation program, the main goal of it is to demonstrate that the CNFs can work on top of a Sylva stack. Okay. This includes the onboarding of the different container images and Helm charts, the instantiation of them correctly over the workload cluster in Sylva, and a basic functional testing of them. Currently, we have a validation center instance deployed on Telefónica's laboratory, and another one that is ongoing is being built in Orange laboratory. The one that is deployed here in Telefónica is based on the OpenStack flavor that Alessandro has commented before, and the one in Orange is going to be built over using the bare-metal flavor of Sylva. About the derivative stack or distribution validation program, I can say now that the main goal, the main idea of it is to demonstrate that any derivative stack or derivative distribution that may appear in the future in the market include the capabilities that has been defined in the community for Sylva. Okay, the idea is here will be to test that any derivative stack at least is ready to cover the different requirements that has been defined in the community. Next slide, please. Thank you. Okay, here in this second slide, you can see represented the workflow of the CNF validation program. As you can see, there are 2 different phases, we can say, or 2 different tasks that are being executed in parallel during the validation of a certain CNF. The first one in the top is the work line related to the deployment of the CNF. is okay, identify the platform capabilities that the CNF under validation requires, install and configure these capabilities in the validation platform stack, onboard the different images and health charts, and instantiate them over the workload cluster. Okay, this is the deployment work line. The second work line that is executed in parallel is the functional testing one. During the configuration of the platform and the onboarding and instantiation of the CNF, there are a minimum functional testing that has to be developed to check that once the CNF has been deployed over the validation platform, it is not only well deployed in terms of Kubernetes resources, but it also can perform basic functionality to check that, okay, we have already deployed the CNF successfully, but moreover, it is being able to complete the functionality that it has been developed for. Okay. Next slide, please. And in this third slide, the last one, you can see the same workflow, we can say, but represented in a timeline. We have estimated that normally for a CNF validation, it is going to last more or less 5 to 6 weeks in the process. You can see there 3 different phases. The first one to configure the validation platform, the second one, the onboarding and distanciation, and the third one, the functional testing. Okay, this third one is we can say that is the execution of the CNF functional testing, because during the first and the second phases, the development of this test or script to test the basic functionality will be developed. And in the top, you can see for each phase different milestones, M1 to M5, that indicates in each phase that we are reaching the intermediary objectives. Okay, like checking that all the first one, for example, okay, milestone 1 is to execute successfully test that tell us that the CNIs or the required capabilities by the CNF are correctly installed in the platform. Okay. The second one is to deploy a dynamic Helm chart that let us know that these capabilities has been installed correctly, and they can be used by a workload, consumed by a workload. Okay. The milestone 3 in the second phase is to confirm that the CNF images and charts are accessible from the workload cluster where we are going to deploy the CNF under validation. The fourth one is to confirm that the CNF is correctly deployed in the cluster in terms of Kubernetes resources. Okay, here we can check that all the pods of every deployment, stateful set, etc., are correctly deployed, they are running and in ready status. And the 5th milestone in the third phase is to pass successfully the CNF basic functional testing. And this is all. This is the full cycle for the CNF validation. So thank you very much.
Thank you, Guillermo. So what we wanted to talk now is in terms of active contributors and what we call followers. So as it was stated, this was a project that was begun by Orange, Deutsche team, Telefónica, Vodafone, and the network vendors Nokia and Ericsson. But now it has the active contributors are increasing a lot, and the followers also. In this call, of course, we want to have even more active contributors, even more followers to join this project. And we are having a lot of great news, and we are achieving a lot of great features on this platform in a very, very short time. To talk a bit about what we have done in the 2022, it was the beginning of the project, so we could, in June and 7th of November, we could release the reference architecture and objectives for this platform. And on April this year, 2023, we have the first public release that we had the use cases requirements for the CU NeuroRAN, for the Free 5G Core and CDN, and we have the Kubernetes distribution. We have the bare metal automation also beginning the pilot for the Kazan bare metal, and the security, the first conformity evaluation. Of course, and as we said, we want to continue to evolve. Here it's the roadmap that we are planning for June and that we are planning for November. So the April is the version 01, is the first public release. In June will be the release 02, and in November the release 03. It's utterly important that we have more people. This is fantastic that we achieved this. It's a great contribution and a great effort for everyone involved. But it's important to have more people, so that we want for this to be a community and to grow the community. That's the purpose of the meeting today, to present this project. Is also a purpose of this meeting to clarify you and for you to understand how you can help, and we know that this project also can help each one of you in your companies. So with no more slides, I just want to thank you. We have here times from some Q&A that you might have. So I saw some message in the chat, but they are also replied. But I don't know if anyone has any questions, if we can have here some Q&A.
Just thanks a lot. Just to precise on the technical steering committees, as mentioned by Andre, we are an open source project, so of course they are public. The next one is next week. In the minutes, we will share the link to the GitLab project. We'll share the link to a community Slack where you can ask your questions in your early stage when you are going to if you want to deploy the stack. And also important is that during next TC, we're going to review the roadmap. So Andre shared the last validated version of the roadmap, and the project is not finishing at the end of this year, so we're going to give more visibility. And that's it on my side as complementary.
And the merchandising, of course, that Guillaume is the only one that is using, but we also have the merchandising in Sylva that you can buy, and of course, with proudly wearing it in your companies to give this promotion of this project. Any doubts? Otherwise, I understand this can be a lot of information. As Guillaume is saying, we are going to send this offline. We are available in terms of if we want to clarify I'm the Spock, and you can contact me. I'm always available. And just ping me, and we can clarify you here on this project. Make sure also that we have more people onboarding.
Thank you very much.
Okay. If not, we get 20 minutes to the next meeting that we will have. I'm sure you also have scheduled agendas. And again, this, as Guillermo was saying, we are going to send offline. Any doubt, we are available. Drop an email to me. And also Guillermo showed here the Leeds Foundation shop. And send an email, we can clarify you.
Okay.
Thank you so much.
Thanks
Thank
to
you.
all.
Have a nice day.
Thank you.
Thank
Have a
you.
nice
Bye-bye.
day.
Bye-bye.
Thank you.
Thank you all. Bye.
Bye.